Hello students, welcome back. In the today's session, we'll take up yet another part of the jet transform. And here what we start with is, we know that given a particular signal, let's say we are given a signal z power of n, which is applied to a discrete time LTI system. And for this, the response will be y of n. So what this y of n will be, I can write this. So we know that y of n can be written as equal to transformation as per the function given on the input z power of n, which is nothing but h of z. So I can write it this way, h of z, where hz is the impulse response of it, dot z power of n, where 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 h of z, it is a discrete time. Remember how you did in the Laplace transform. There we said hs is equal to the integral from minus infinity to plus infinity of the given signal e power of minus st dt. So here in this case, in the case of a discrete time, so this will be a series summation. So therefore this can be written as equal to summation of n is equal to minus infinity to plus infinity of h of n, a discrete impulse z power of minus n. Try to correlate it there with the continuous time system. For the case of a Laplace, we said h of s was equal to integration from minus infinity to plus infinity of ht e power of minus st dt. But in the case of a discrete time LTI system, your response hz is equal to minus infinity to plus infinity summation h of n z power of minus n. Now for a suppose you are given, you have some arbitrary signal, a discrete signal x of n. For hn, the response is hz. For xn, it will be x of z. So simple. So therefore, I can write this. This will be h x of z is equal to summation of minus infinity to plus infinity of x of n into z power of minus n, where you can make a note of it, where your z is nothing but a complex valued, is generally a complex valued. It is a complex valued, and the value of z is given by r dot e power of j, and you can let it as omega, where r is the amplitude, r is the magnitude, and omega is the angle. Omega is the angle of z, angle given by z. So with this one, equation 3 is, so this equation, this particular equation, let me highlight it, as can be clearly seen. It is a bilateral. It is both sided. So as it can be clearly seen here, let me highlight this. As you can see, this is a bilateral or a two-sided jet transform. So if I mark this as equation number 1, so equation 1, as can be seen, is a two-sided, is bilateral, or it is a two-sided jet transform. Now, contrary to it, so that means this can be written as minus infinity to plus infinity plus 0, plus then 0 to infinity. So we can write down from this as one-sided jet transform. You can derive it yourself from the equation number 1, that if it is one-sided, that means from one part, that is if you say x of minus n is equal to 0, then we can just neglect the summation from minus infinity to 0 or to minus 1, and only the summation from 0 to infinity will remain. So in those cases, I can write it as x of z is equal to summation of n is equal to 0 to infinity of x of n z power of minus n. And clearly, as you see, the limits are from 0 to infinity. So therefore, this is a one-sided jet transform. Now, what is important? That you will be given a question. Okay, find the jet transform of the given signal. So what you need to do is, so in the numericals, when you solve the numericals, what you need to do is, one, you need to find x of z, that is find the jet transform. And finding the x of z of a given signal is not sufficient. You also need to find out the ROC, region of convergence. So once these two things are found out, only then we will say the answer is complete. So therefore, both the x of z and ROC are required to be found out in simplifying the questions given in the jet transform. Well, hope this equation number 1 and equation number 2 will help you in solving the different questions or based on the different signals. We'll see the practical applications of the jet transform in the next video when we discuss how to find out the jet transform for the different given signals like the step function, the ramp function, and so on. So till then, see you in the next video.